Chapter 11, Randomness.
I love that.
Collecting data.
At least they're straightforward.
I mean, you know, just had to be blunt. If we want to generate data that gives an accurate picture of the world, we must rely what is happening.
Oh.
It literally just did it dot by dot.
Trying to do a prank or something.
We must rely on randomness. The W is just being an example of randomness. Why is the screen yellow?
That's another example of randomness.
Just keeps happening.
Yellow is my favorite color. So I don't mind it.
I like yellow.
It's a very warm
It's yellow
color,
again.
Oh my god.
Only when you're writing.
Yeah, it like unfades to.
We can get random numbers through a random number table, which I will give you. They're in the back of your book, but I'll give you a couple printed copies when we get into examples, because a few of the examples we will use that so that everyone's looks the same and is consistent, or at least we'll be able to walk through it a little better by having that. Computer number generators. Computer. I feel like that's spelled wrong. Number generators. Or like dice. Because when you roll a dice, the number that pops up is random. It's not like it's, you know, not like a 6-sided dice that has the number 6 on all sides. Like, obviously that's not random, but a normal dice. And that's just a few examples. Your calculator would be considered like a computer number generator. Your calculator actually has a random number generator on it.
Whoa, that's cool.
There's a lot that you can do with your calculator. We can, actually, our calculator will flip a coin for us. Our calculator can pull cards out of a 52-card deck.
I think I've messed around with that stuff before.
It's pretty cool what it can do.
Josh has dabbled in the arts.
Yeah.
Can't play Mario on it, but you can, you know, play cards and chess and all that on it.
And also graph inequalities.
It's very true. Well, I'm not sure if this calculator does,
Mine does, though.
but I think it does, but it's not as cool. Because it's just black and white. Oh, wait. Building a simulation, not simulator. All right, so using randomness to predict an outcome. Now, I'm going to tell you these next 7 things. You need to know them as a concept question for quiz, test, whatever. They will be written again, more than likely, in the concept questions, but I'm just letting you know you're going to need to know these in order.
Okay.
I know something that's really random. My handwriting. Sometimes it's neat, sometimes it's not.
Same.
All right, so I first identify the repeated component. Two, explain how you will model the component's outcome. So these steps are like, we will do these steps when we do the problems, but some of them might just be like understood in your head. You think about like the identifying the repeated component could potentially be something that's just done in your head.
Okay.
But like step 2, that would actually be writing out, how are we going to model this? 3, specify how you will combine components to model a trial. 4, state clearly what the response variable is. 5, and the easiest one, run several trials.
Watch me forget that.
Now, what I'm going to tell you is we are going to get to a point when I might actually write it in the notes, but several trials is a minimum of 3. But in general, we want to run 20 to get accurate information.
20 sounds a lot more like several.
You will. I'm just saying, like, you might want to make a note that if it says to run the trials, you always want to do a minimum of 3, and then usually we were looking for actually about 20. It will come up again later in the notes, but I just want to go ahead and put that in your head so that you're familiar with it. 6, collect and summarize the results of the trials. And 7, state your conclusion in context. Now, these stating the conclusion is a little easier to do than stating the conclusion of some other things that we do. Like, it'll be like, on average, how many trials you need to do before you get whatever. So, the rest of the notes are basically one long example. So it's about a 1.5-page long example. So it's going to be the example problem, and then we're going to work through the 7 steps so that you see it. And so within that, that's where I'll explain the thing about the trials and all that. I'm going to go ahead and write the problem, and then I'm going to let y'all catch up. Where are y'all at on here so I know how far up I can slide?
Like, done.
I'm done.
You're done. Oh, perfect. I can go all the way up. All right, so the example, a candy company, it's like Willy Wonka, is giving away, not golden tickets, but a prize to consumers who collect, not tickets, but a red, a white, and a blue game piece. I always imagine like those like the game pieces from like Sorry.
Yes, like the original Sorry. I love that game.
You know what I mean?
Yeah.
Anyways.
Like the little they're like little, yeah. They go like that. They look like little Hershey Kisses, but like.
Seems like so much effort though. You have to collect 3 things.
That's. Yeah.
Kind of like the little Santa hat Hershey Kisses.
Yeah.
But yeah, that's what I always think of when I think of a game piece. But, I guess you could think of like Monopoly game pieces that are different colors. I don't know. Anyways, that's not really relevant to the problem, but regardless. Blue game piece from each of the candy bars, or from their candy bars. Each bar has 1 game piece in it. pieces. 50% of the pieces are red. 40%, I'm going to use yellow since I can't write in white. Oh gosh, that's not good on this color. 40% are white. And only 10% are blue.
So if you got a blue one first, then I guess you're lucky.
Are y'all old enough to remember when McDonald's would do the Monopoly games on their cups and the fries and stuff?
Yes.
So it was like that. So like they would have certain pieces that were really easy to get,
Yeah.
and then there were a select few pieces that would be really hard to get.
I remember doing that.
And so, anyways, similar idea here. Game pieces that they're talking about could be something more like that. To be honest, I have no idea, but again, not exactly relevant. Just what it makes me think of. So they say to conduct a simulation with 3 trials. So they specify in this one that we're only going to run 3. To predict how many bars you would need to buy to win the prize. So we're going to work through this step by step, okay? So we're going to work through, like, what's the repeated component? That's going to be the first thing. And then we're going to be using a random number table, which... well... yeah, we'll just... let me get out a random number table really fast. I haven't...
Oh,
yeah.
Calculators for this.
For what we're about to do? I don't think so. How many of these do I have printed? I might be able to go ahead and give y'all one. Go back. Nathan won't be able to see it, but oh well. So sorry. Alright, I can go ahead and give y'all each one.
Those are pretty random.
So a lot of times, if it's a problem on a test or a quiz where I need you to give me something specific, I may tell you what rows you need to go from so that I make sure you actually know what you're doing, because otherwise I mean, you could just be pulling random numbers out of thin air, or you could be using your calculator potentially for something. But on the exam, if you need it, I'm pretty sure they give you a random number table, and then you just basically pick whatever row you want out of the table, and then you just work your way across. But anyways, do y'all have the whole problem written down? Alright, so the first thing we're doing is identifying the repeated component. So the component that's repeated is that there's one game piece in each bar. I thought she was coming to ask me a question. I was like, you could ask me from over there.
No, I was trying to
The second thing that we're going to do is to explain how we will model the component's outcome. So this is where we're going to explain what everything is for. So basically, I'm going to use a random number table. Okay, so if you were going to use a calculator, this is where you would say, I'm going to use the random number generator on my calculator, things like that. And I'm going to specify single digits, and I'll explain why in just one second. So single digits from 0 through 9, okay? And that's because I have 100% total. 50. There's no rogue color pieces that are irrelevant to the thing. Every piece is relevant. I just need one of each one.
Okay.
And so I've got a 50% chance of getting red, a 40% chance of white, and a 10% chance of blue. And so basically, I'm going to assign a number to each percentage, or a set of numbers to each percentage.
Okay.
So I've got 10 numbers that I'm dealing with. Since these are all even percentages of like in increments of tens, I'm going to call the number 0. When I get that, that's going to be a blue. So 0 on the random number table is going to be equal to blue.
Can you just like pick that? Like, could it be 3 if you want it, or like, or should you go in like order?
Go in order, because we're going to be using all the way 0 through 9. Now, you could have started with with white and done that 0 through 3 is white, but I'm just going increments basically, but you can do them in whatever order. That part doesn't matter, but don't be like, well, 3 is going to be blue and 1, 2, and 7 are going to be red, or, whatever. Like, they need to be in order, because otherwise it kind of loses some of the randomness to an extent. So 0 is going to be blue. 1 through 4 is going to be white. And obviously I'm not writing piece, but these are all pieces of the game. And then 5 through 9 is going to be red. Now, any idea why I said we need to use single digits and I didn't go 1 through 10 instead of 0 through 9? Specifically in regards to the table.
Like 10 is a double digit number?
Yes. 10's double digits. So as I go across, basically what's going to happen is I'm going to work across. I'm going to go down to like row 19 for the moment. So this first one, if I look at it, is where row 19 is a 6. So that would have been red. Then 7 would have also been red. 8 is red. 1 is white, and so on and so forth. So if I all of a sudden have to worry about a 1 and a 0 being beside each other, then I have to try to figure out, well, that one was counted as 10, so if you want to use double digits, what we would have needed to do would be use 0, 1 through 1, 0. Everything would have to be 2 digits. So you can't like intermix single digits and double digits, basically. Now, when you do it on your calculator will ask you what the minimum number you want to use and the maximum number. And when it produces a number, it will produce, like, if you say 1 through 10, it will produce the number 9. It will produce the number 10, because a random number generator can do that. On paper, we can't do that, so that's why we had to specify that. So, just to explain what we did here, for if you go back to look, basically all of this over here, the numbers will match the percentages. Okay, meaning I had 10%, so I just had one number that covered that for blue. For white, I had 40%, so there are 4 numbers that are covering that, and so on and so forth. Specify, will some numbers be ignored? So that's more like if you have 5 options, and so we're only using 1 through 5 or something like that, then 0 is getting ignored, and then 6 through 9 is getting ignored. So basically it's just saying I'm ignoring any numbers that aren't in my data set. But in this case, I'm using all single-digit numbers, so I'm not ignoring anything. Do you need to ignore repeats? So sometimes it will specify that we cannot have any repeated numbers. Sometimes it won't. It just depends. If we had non-10 base percentages, we would use double digits. Or a calculator would be the other scenario. So if we had, like, there was a 32% chance of white or something like that, we would have to use double digits, and rather than using 100%, we would use 0, 0, basically, for that 100%. And at that point, any single digit number like 7 or whatever would have to be 0, 7 to produce a double digit. When we actually do our examples off the worksheet, you'll see some where we do that. So then 3 says to specify how you will combine the components to model a trial. So basically for each trial, I will continue choosing numbers until I have a red, a white, and a blue piece. So basically I'm trying to see, which is what I'm about to say in number 4, how many trials or how many candy bars do I need to open before I have gotten all 3 pieces, is what I'm going for. Then 4 says to state clearly what the response variable it is, and so that's going to be basically count the number of trials, until collection is complete. So that's basically what I was just saying. Then 5 says to run several trials. They specified in this problem that we're running 3 trials, so that's how many I'm going to do. And so basically we're going to run the simulation now. And now I'm using trial kind of interchangeably. I'm running 3 trials, but within that trial, there's still more trials happening because every candy bar is a trial in the big trial, if that makes sense. So I have, obviously we've already labeled up here what everything is. And so trial 1, I'm going to use row 1 of the table. And so every time I get a number, I'm just going to write down either B, R, or W for blue, red, or white. And once I have...
May I have your attention, please? May I have your attention, please? Just a reminder, students on the fundraiser party list are allowed to go to the gym at 1:30. Again, students that are on the list, teachers please bring them or send them to the gym at 1:30. Thank you.
All right, so once I have a blue, a red, and a white, I will stop immediately, count up how many candy bars I had to open, and then write how many I did. Okay, so the first one, try to get this so I can see. So I get, initially, 9 is red, 6 is red, 2 is white, 3 is red, or sorry, that was 4. 4 is red, 5 is red, then 6 is blue, and so now I have one of each color, and so it took 6 trials, or 6 candy bars, to complete.
Okay. Oh. I don't know why I thought we were going to have to go through all of it.
So this was, I'm just going to mark that we used row 1 for that, in case you go back and you're like, how in the world did she get that? All right, somebody pick a row. Tell me what row we're going to do.
17.
Row 17. All right. So trial 2, we're using row 17. So 1 is white, I'm just gonna say this. The number 3 is white. 2 is white. 0 is blue. 5 is red. So in this case, 1, 2, 3, 4, 5. That took 5 trials to get one of each. So 5 trials until complete. And that was row 17. All right, somebody else pick another one. Another 8. All right, row 8. So trial 3, this will be our final trial. Keep looking back at my thing. All right, row 8. 7 is red. 2 is white. 7 is red. 5 is red. 3 is white. 3 is white. 6 is red. 2 is white. 1 is white. 6 is red. And then 0 is blue. So I have one of each now. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So 11 trials until complete on this one. And that was row 8. And so typically when you're running 20 trials, I'm probably going to be having you use your calculator most of the time instead of having to go through 20 rows on this table because that's kind of crazy. But so basically what I'm going to do in 6 is collect and summarize the results of the trials. And so that's essentially I'm going to find the mean, the median, so what is the middle value, and so the middle value in this case is 6. The mean is 11 plus 11 is what, 22 divided by 3 is 7.3-ish. 7.3 repeating, something like that. I don't know. Ballpark.
Ballpark gets very specific.
Obviously, we would want to be more specific, but these aren't the numbers on my paper, so I'm just we're running out of time.
Yeah.
The max value is 14, and the min value is 5. Nope, sorry. I'm looking at my paper. Max value was 11 for us.
Okay, I was like.
Now, what is it possible that the minimum could be? 3, okay? This could be as low as 3.
I was looking at the random numbers, and if we had picked row 22, then it would have been 3.
So, this is obviously if we want to be more confident. We would complete way more than 3 trials. Like 20. So obviously 3 isn't a really good representation. We would really want to run 20 to get accurate numbers. And so then the last part of this problem, there's 2 more lines after that, but we'll just have to save that probably, is the conclusion, unless y'all just want to finish writing. But on average, you need to buy 9 candy bars, or wait, nope. Well, we can't have a part of a candy bar, so we would round up, okay? 8 candy bars to get all 3 game pieces. However, to be sure, you might need to buy oh my gosh, I cannot spell. Buy up to 11 bars. Okay. Now, obviously, you could potentially need way more than that. Okay, you could need 100 bars or something. It just, you don't know. So, anyways, that would basically be what a problem like that looks like. There's about 2 more lines that we'll need to write on there. One of them is what I commented about, where I said we need to buy 7.3 candy bars, and I said, well, we can't have a part of a candy bar. You can't buy a third of a candy bar from a grocery store, so you need to round up. So that's going to be basically the next thing that gets written, and then the last thing is that simulations are used to check the likelihood of an outcome. So basically, that's it in a nutshell.
Okay.
That's chapter 11.